Okay, so let me write down some exercises that we're going to do really quick for warm-up. Let's see. I have markers and erasers right up here at the front. Okay, and let's begin. So warm up. Okay, warm me up, right? Let's find the average rates. So what does that mean? Okay, possibly mathematically, finding the average rate of functions or of given functions. Oh, okay. Thank you very much. Yeah, you can go ahead and yeah, just leave it like that. Is that okay, guys? Yeah. Or do you guys want all the lights off? No. Okay. Oh, we'll keep it this way then. Half lights off. Okay. Average rate of functions on each given interval. And then the function is f of x is equal to cotangent of x. So if you want, you can bust out your calculator for the upcoming problems, right? So here are the following problem, or here are the following intervals. Pi over 4 to 3 pi over 4. And b is simply pi over 6, comma, pi over 2, okay? So I want you to try to disseminate what this question is, find someone to talk about it, what the heck the average rate is. Think about it, talk about it, and in the meantime, I'm going to call out your names for your exams as I'm passing them out, okay? All right, guys, this is your next example, or your next, your next problem for like the next 5 or 10 minutes, okay? So find a space on the whiteboard. Actually, yeah, just get up right now. I don't know. Everybody, please get up. Find a space on the whiteboard. You don't have to write this down, and then just try to figure this out. If you don't know what to do on the board, go around and talk like, okay, what are we doing? What are we doing? I don't know. Okay. Okay, and Elena Thompson, please come up here. I have your exam. Okay, Miss Alana, let me give you your so it's Gailey. Tell me if you see your name. I am. Oh, yeah, there it is. Okay. You are Miss Thompson? Okay, thank you. Mr. Stevie Romero, please come up and grab your exam. There it is. Okay, good sire. Here you are. Miss Teresa Gailey, please come up. Here you are. Okay. Miss Emily Bailon, please come up and grab your exam. Here you are. Joseph, Greta, and Gwen are not here at the moment. Okay. Fair enough. Does anybody want a hint for what these are? Average rates of functions? I'm asking for the slope. Yep. Average rates of function. Rates, average rates. Get it? The average rate of change, right? That's what I'm asking for. The average rate of change is simply a really fancy way of saying, can you just give me the slope? Okay. And these are x coordinates. These are x coordinates here. These are both of these. This to this is x coordinates. These are x coordinates, right? That is your clue. Okay. Greta, please come up here. I have your examen to give back. Greta. Okay, very good. All right, we're gonna put this away here. I'm gonna walk around if you guys need help. Anything? these are x coordinates, so if you need to find slope, right? If you're trying to find slope, what is the general formula for slope? Right. And you have two x coordinates there. So how would you find the y coordinates? Plug into this equation. Well, we're given a function, right? So if you plug in your x value into the function, you get out the y value. So that's how you find the y value. Let me kind of give that to everybody right now. Anybody stuck on this? Yeah. We have some people stuck on this. It's completely normal. Oh, I don't have to write it up here. Okay, if you want to look up for a clue, I will give it to you. So we know that slope is equal to y2 minus y1, right? The change in y or the change in x, right? We have, these are intervals of x. So this is from x is equal to pi over 4 to x is equal to 3 pi over 4, right? So we have x2 and x1. How do we find y2 and y1? Well, we're given a function. So all you'd have to do is really just plug these in to get the y values. So if I wanted to find the y value for pi over 4 at x equals pi over 4, I would plug in y over 4 into this equation to get my y2 or my y1 value. Okay? And then you do the same exact thing for this. Okay? So this is just a nice, or not a nice, but a very like, what is it? What do you call that? Rigorous way to figure out or to ask you to solve for the slope. So it's just kind of a mean way to ask you, can you just find the slope of these x values here? Okay. So I'll give you a few more minutes. Go ahead and work on that, knowing what you know now. Okay. And then I'll show you the key, or I'll show you like my little answer key. So this is actually some of your first problems on your homework for this month. And then go ahead and just talk with a neighbor too. You know, check your answer with your neighbor to see how you guys are doing. Okay, so don't try to ever solo, anything. I think, check around, talk around, and ask how people are doing. And don't be afraid to be honest too. Like, I'm having trouble with what's going on, right? Okay, I'll give you guys like 2 more minutes. Just try your best to find this out. guys, I'm going to start in a few seconds. So go ahead and wrap up what you're doing, and then we're going to kind of go over this. Let's see if we're still recording here. Okay, good. Okay, so let's go ahead and stop where we are, right? I'm going to go over, I'm going to unfreeze the screen. Emily, could you get the lights for me? I think it's still kind of glary. So don't know how counterintuitive this is, counterproductive, because we all might kind of fall asleep here. Okay, if I was a student, okay, I'd be like, man, calculus is not the way to start the morning. Okay, for some of our brains, I might be wrong. Some of you guys, it might be the best way to start the morning. Okay, I'm trying to empathize with how you might feel. Okay, so on number A, you don't have to get the notation down, but I just want to show you where I'm coming from. Okay, because I'd like to start here, right? But I know that kind of might throw you for a loop about why I plugged in cotangent of 3 pi over 4 minus the cotangent of pi over 4. Why did I choose to do that, though? Can anybody explain or help to describe why the heck I did this? Why do I have this, and where does this number come from? Okay. Yeah. Go ahead, Stephanie.
First off, it's like the cotangent x is the function, and from 2 and 3 pi over 4, and pi over 4 are your two x values that you want, so you put them in for the y value, cotangent of those numbers.
Okay.
Y values.
Okay. Okay, so those are your y2 and your y1 values, right? Because I plugged in the x values into this function, giving me the y values. And the bottom, where did 2 pi over 4 come from? Yeah, because you're subtracting x squared, or x to this, or x2 minus x1. So in other words, this is what you did, okay? You plugged in 3 pi over 4 into the function, and you subtracted the function of pi over 4. That's your y2 minus your y1 to find the slope. And then your x2, I kind of arbitrarily made x2 3 pi over 4, and then x1 pi over 4, judging from the way I wrote my notation on the top in the numerator, right? If you plug that into your calculator, like as such, and by the way, 3 pi over 4 minus pi over 4 is 2 pi over 4, right? If you plug that into your calculator, you should have gotten something like -1 minus -1. And on the bottom, this simplifies down to pi over 2. And in the very end, I have -2 divided by sort of like a fraction of pi over 2. And if you know your algebra, you would know that in the very end, if you have a denominator in the fraction here, I look at it as whatever's in the denominator in a fraction of the denominator of a bigger fraction. I think of the lower number going back up to the top. Okay, so you have -4 over pi as your final answer. That is the slope. That is the slope between an interval of these 2 points. Okay, so if you can imagine, I don't remember what the cotangent graph looks like. You don't have to draw this, but let's just say it's this curve here, okay? From pi over 4 to 3 pi over 4, the average slope from here to here is -4 pi. Oh, -4 over pi. What does that indicate to you about my graph? If I have -4 over pi as my slope, is my graph correct? What is incorrect about my graph? Yeah, because it's negative, okay? So just some basic review, right? Okay, anybody want to tell me what they got for B? Just give it a shot here. Did anybody finish B? Raise your hand if you finished B. Okay, all right, great. Okay, all right, it's okay, Ashlyn, what'd you guys get? Square root 3 over pi. Let's check it out. Okay, so -square root 3 over pi. Okay, let's check my answer. I mean, I'm very prone to making mistakes if you haven't been already able to tell. So that's my answer for B. This was written quite a long time ago, so let's see. I did the f of pi over 2, which is my second coordinate. Did I write that down right? Yeah, pi over 2 minus f of pi over 6. And then that's the cotangent of pi over 2. I got 0. And then over here, I got f of pi over 6 is root 3. So that's negative root 3 on the top. And on the bottom, I made this pi over 2 minus pi over 6. I wanted to get this the same denominator as pi over 6, or the same denominator as 6. So that meant I had to multiply the bottom by 3 and the numerator by 3. So I get 3 pi over 6. I subtracted pi over 6 from this, and I got 2 pi over 6. And I think that simplifies down to pi over 3. And I move the 3 up towards the top. Did I make any mistakes here? Okay. Not trying to show off too, like, oh, did I make any mistakes here? I mean, like, no, did I really make any mistakes here? It's an honest question. All right. If you guys would like, you guys can write that down. But do you guys now recall how to calculate slope, given this stronger vernacular, I guess, or this, not vernacular, but stronger vocabulary and asking you how to do that? Are you guys a little bit more comfortable now with this concept? Okay, well, hopefully you are, okay? Because we're going to move on and we're going to continue doing this. So we're going to look at another problem that asks you to calculate slope in a slightly different way. And this is from, so most of the notes that I graph from are directly from your book, but I'm just here to kind of explain to you the main points, the key highlights of each chapter, okay? So kind of give you a heads up, we are in 2-4 or 2.4 rates of change. I'm going to say ... So you might want to write this down. Rates of change. Oh, tangent lines. Okay, so now we're going to talk about tangent line, or the rate of change for tangent lines. And sensitivity. I don't know if we're actually going to talk about sensitivity today. Mathematical sensitivity, right? Not social sensitivity, though I would like to touch upon that subject. I'm not quite the expert in that field, okay? So we're going to talk about mathematical sensitivity. Okay, so here's another example. And I'll do the first one, but then you guys can do the rest. I want to see what you guys end up getting, okay? We're going to estimate the slopes. So you can write this down. Estimate the slopes of the secants. The secants PQ1, PQ2, PQ3, and PQ4. What could that possibly mean? And it says arranging them in order. Arranging them in order in a table. What? I don't know what's happening. In a table. Oh, that's not a question. That's a command. Okay, I'm sorry. So, whoops. Should have been, that's not an exclamation point either. I guess you can make it one if you wanted, but that's supposed to be just a solid period, okay? Like a statement. All right. So, we're going to estimate the slopes, and then I think that's part A, and then part B is to estimate the speed at point B. Okay. Estimate the speed at point B. Point B. Okay. It's a little bit harder to do any of this without a visual. So I'm going to give you guys a few seconds to write down what I just wrote. I'm going to show you the visual that goes with this problem, right? Which one is this? Okay, so here's what we're looking at. It's literally in your book. There we are. This is exactly what we're looking at right now. Oh, and I'm sorry, it's supposed to be this at point, yeah. I think it's at point B or point P. Well, anyways, Yeah, I'm sorry. So go back on question B. We're going to estimate the speed at point P. Okay. And here, look at the units specifically. Okay. Actually, what is this graph for? What is this graph telling us about? What is this graph about? I don't know what this graph is about. What are we trying to estimate here? I don't get it. Any ideas as to what this means, what this graph is saying? I'm gonna hold off on you, Stephanie. I want to give someone else a chance to maybe talk about this. I mean, think about this for a second. Look at the units, look at the axes. What is this estimating? What are we talking about? Any ideas? Yes, Joseph?
It's the distance time graph, and the slope is the speed.
How would you know that the slope is the speed? I don't know.
The speed is the distance over time.
Yeah, so if this slope is the change in the y over the change in the x, right? So we're just estimating the speeds of a Ford Mustang. Is that even still a relevant car, by the way? Yeah, it is. I don't know. Because I don't know if they discontinue that. It's like, oh, Mr. Wee, we're on like the Ford Scavenger or something. Okay. All right. So what we really want to see is at 20 seconds and at 650 meters, we want to find the slope at that one particular instant. That's something we haven't learned about yet. Okay. I'm not talking about the slope between 2 points, right? Like we take the average of these two and find the average change over the average. Yeah, average change in distance over time. Eventually, I want to find that slope at just 1 point. That's something we have not learned yet. So we're going to estimate it. So what we're going to do is we're going to find the slopes between Q1 and P, Q2 and P, Q3 and P, and Q4 and P. Oh, sorry about that. First off, give me an estimate or coordinate for what this is. What is Q1? What would you say the coordinates are for Q1? Roughly.
10,
Okay, 10, comma. Yeah, sure, 230. Okay. How about Q2? What is the coordinate for Q2, guys? What do you think? All right, 14. All right, 380. Okay. How about Q3? I got. And you can be strategic here. You don't have to pick hard numbers here. We can pick maybe easier numbers if you want. Emily, did you want to? Yeah, 480. I like that. Okay. And then how about Q4? Anybody?
but it's above the 500 line. I mean, I've been.
Yeah. No, I completely. Yeah. I know. It's a mis. Yeah. This Q3 is below the 500 line, but Q4 is above the 500 line.
I know
All right.
idiots.
No. Don't. Wow. Don't jump the gun here. Okay. Like I'm a straight idiot. No. Don't do that, please. Okay. No such thing. Okay. I'll give this one out. I'm gonna give this one a try. 18 and something else. What should we call that? 18 and 560? Can someone tell me P? What the coordinates for P are? What is it? 20 and 650. Okay. And this was already pre-written in the book, was it not? Right? There's no way Mr. Wee just wrote that whole thing in because that'd be writing in the book, and that's not what we're doing today. Okay. So this was already pre-written in the book. Oh, how convenient. It's already written in there. Okay. And now we're going to estimate the slopes. All right. So this is what they meant by the table. If you can recall, we're going to make a a little table here, and we're going to find the slopes. How did I write this in my notes here? Let's organize my notes. We're going to write a table of secant slopes. Okay, secant slopes. And then we're going to say what PQ is equal to, PQ1, and then we're going to do PQ2, PQ3, and PQ4. So if I want to estimate the slope of PQ1, then let's take a look. I know I'm kind of jumping back and forth here, but we're going to take the coordinate for P to Q1, and then we're going to find the slopes between those guys, between these 2 points, okay? So it will be, I'm going to take the y value, 650 minus 230 over 20 minus 10. Then we're going to have, I think what would that be roughly equal to? That's 420, yeah? Over 10. Can someone give me quick math here? What does that equal to? Yeah, that's 42. And what are the units for that? What are the units? It's y value, right? So in my y-axis, I'm looking at meters, right? So up on my y values, I'm going to put meters in meters. And on the x-axis, I'm going to put what looks like seconds. Seconds. And then my final unit is going to be meters over seconds. What do you know? 42 meters over seconds. Okay, guys, why don't you guys work steadily on PQ2, PQ3, and PQ4, okay? I'm a little lazy, okay? So why don't you guys work on that, and then when you guys can, provide me a point or coordinate. As you're doing this too, let me explain that on your exam, your unit circle, the way it factors in, I know it says 40 out of 48 points, all right? But it's not really worth 48 points. It just made it easier for my TA to grade if because really the whole thing is only worth 4 points on your exam. Think of it as a long question. I'm super sorry about that. I know you're like, this could boost my grade. But add 4 points to your test grade. Okay. So if you got, let's say, a 60, okay, 60 out of 70. If you add 4 points to your grade, now you have a 64 out of 74. It really didn't change the percentage much. Pretty much everybody in this class got a 4 out of 4 on their unit circle. You guys did really well on it. Okay. Anybody get PQ2 so far? So sorry. Yeah, no worries. Okay, back corner. Did you guys get PQ2 yet? Anybody get PQ2? No? I'll, I guess cut in and I'll do PQ4. So I do 650 minus 560 over 20 minus 8. Bless you. I believe that's 90 divided by 2. That's about 45 meters per second. So I got PQ4. Emily, did you get an answer? Cool. What? 45. Great. Okay, I like it. That looks good to me. What about PQ3? Okay, all right, fair enough. Okay, so we got 4 different slopes, right? If we had to make a guesstimate, what do you think the slope at P would be? So we have average slopes here, but what about that instant slope? Judging from what we have here, does anybody want to make a guess for it here? What could possibly be the speed at that instance of P? If not the exact number, what should it be around? What should the speed be around at that instant? Yeah, yeah, I was gonna say, yeah, Joseph. Sorry, I didn't know if you had your hand up. Yeah.
How does the speed go down if like the slope increases?
Yeah, I'm not quite sure how that worked. Maybe it was my I know, it's like a big question mark. Maybe it's our guesstimates aren't our coordinates. That's all it could be too, I think. Maybe the accuracy in which we made our coordinates. So, but generally speaking, you don't do this in your notes, but I just did a big circle there. Do you guys see that it kind of flutters around 45 meters per second, right? But do you see how this is a really inefficient way to calculate the slope at one point by guesstimating or kind of estimating a bunch of slopes near and approaching P, right? Well, today I'm going to teach you a way to do it where, I don't know, it's going to be it's going to not seem quite as efficient, but we're going to lead up to something that's called derivatives. I don't know if anybody recalls what they did with derivatives last year in pre-calculus. Yeah. There's a meaning to that. You didn't just learn it to learn it, okay? I mean, this whole class is about derivatives and integrals. That's it. Okay. So, yes, Stephanie? Oh, I know I'm kind of saying this thing about finding a slope at one point. Why is that so significant, though? Why is it that I can't just take the slope at one point? Can anybody? What do you mean by that? Wait. What? Yeah, I mean, let's look at the format that we have slope in right now, right? You need 2 points to make it work, right? If we want to find the slope, it's usually a slope between 2 points. There's another name for that. That's called secant. Wrap your head around that because, get it? We found a bunch of secant slopes. We found a bunch of slopes between 2 different points, right? But let's say at point P, I'm at point P is 20, 650. It wouldn't quite make sense to do this. Since I'm doing it at one point, all I got to do is plug in 650 minus 650 over 20 minus 20. Uh-oh. Yeah, what? This doesn't make any sense. So this technique does not work. It has a limitation within the confines of algebra. And that's what kind of makes calculus. We find a way to actually find the slope value because obviously there is a slope at that instant, right? You can kind of see it's going up, right? It doesn't just go 42, 45, slope of 45, slope of 46, bam, 0. That doesn't make any sense, right? If we knew that this graph continued on. That just doesn't make conceptual sense. So in calculus, we developed a way to calculate the instant slope at one particular point. There's a lot of applications with that, okay? It might not seem significant, but it's huge, okay? In fact, this is a very practical subject in math, okay? So let's go ahead and begin to do that. We're going to begin by looking at this. Where are we at here? Okay, so bear with me. It's going to be kind of weird conceptually, but I think this is the slope here. So we're going to find a tangent slope. If you don't remember what the difference between tangent and secant is, let me give you a brief rundown. A secant is between 2 points. Tangent is at 1 point. We were able to find the slope between a secant, or like a secant, like as a noun, a secant between 2 points. Now we're trying to find the slope at that one particular instance, okay? Here's the notation for what you're going to see. The limit as h approaches 0 of f of x plus h minus the f of x over x plus h minus, I think if I'm doing this correctly, hold on, let's not jump the gun here. Oh, no. Let me get some white out here. I made a mistake. Okay, it's just the bottom part, guys, so don't worry. The top part's correct, but the bottom part, oh, fish sticks. I got it. Okay. Over, I'm not done yet, h. Does anybody know what the heck is going on? What is this? I don't. All right, I've lost my mind. Okay, my mind is now in chaos. Okay. Let's look at a graph to understand the concept of what is going on. What is happening? What is happening with my life? Okay, I don't know. Okay. Do I have a better graph? I guess this is like the graph I can use. Okay. Doesn't this make a lot of sense, right? Okay. Now, let's just ask, all right? Let's just figure out, let's look at this line, dissect it one thing at a time, okay? This blue line is the function. Your task, you don't have to read through this. The only thing that I really want from this is, can you find a slope at x equals 2? Okay? Let's find out the slope of at x equals 2, the instantaneous slope. If you can kind of see, the black line, right, is their attempt to find out the slope, the average slope between 2 and maybe a different point, right? That's the standard secant slope, right? The slope between 2 points. That's not what I asked for, though, right? The question is not asking for the average slope. Do you guys see the red line? That's the tangent slope. Look how it differs. That's why it does matter. You can't just take the secant slope because it's not accurate. That gives you a higher slope value. We need to find a way to develop a way to find the slope at that particular instant right here, the tangent slope here. Okay? So here's what it would look like. You don't have to write this, okay? It's the same idea. Let's say that we took the f, and let's replace the x with 2. So we can kind of make sense of this. And let's take a look at what I just have. I have this weird statement here. I'm using a limit now to find out this one instant slope, because a limit's going to help me a lot. Let's make a distance between 2 and some other point that you can't see at any point. We call this distance h, okay? Like the distance away from 2 to some other point is h. That's why in this diagram you have the delta, like the difference of x is h, right? It's just some weird distance, okay? In fact, they just arbitrarily made the distance 2 plus h over here. It doesn't matter, okay? So it's not like it's anything new. This is your y2 at the top, right? This is like, we're looking at some arbitrary point that is 2 plus h, okay? It's like some x value that's 2 plus h. And then your y, I'm sorry, not your, this is your, this is your x2, and this is your x1, okay? And the f, I'm sorry, what? So these are your x values down here and here. These are x2 and x1. The f of 2 plus h is your y2, and then your f of 2 is your y1, right? If you think about it, that's nothing different. That's y2 minus y1. And it doesn't look like it, but look at the very bottom. My x2 would be 2 plus h, right? Or 2 plus h. That's my x2 minus 2, which is my x1, right? And you might be wondering, why is he doing this? Why is he writing this? Well, what is 2 plus h minus 2? What are we left with? We're only left with h. The 2 and the 2 kind of cancel out. So that's why I end up having h at the bottom, okay? So it's nothing new. Trust me, it's nothing new. But the only thing is h isn't a definite number. And with that indefinite number, I can kind of play around with it and say, let's make this a limit. And let's say the distance, h, what is the number? What is the number? What is the limit of this guy if the distance approaches 0? Meaning this, if the distance, I make the distance close in so that h essentially disintegrates, the distance approaches 0, I can kind of trick the system by finding a definite number. If I treat this problem like a limit problem, which I'll show you how it looks, okay? If I treat this whole weird thing that normally should give me 0 over 0, it should normally give me 0 over 0, but if I treat it as a limit, which we have in the past, we can approach a real definite number, okay? So that's what that means. You find a point, you add h to it, you find the y values for it, and you make the distance of h approach 0, then you will definitely get a real number. You will get a real number. This is a way to find the slope at one particular point, okay? So that's the concept. That's the general concept. Now let's go through an actual problem. Okay. So here's an example. Okay. So let's see. We're going to be given, what is this? What page is this? This is page 94. This is problem number 11. Okay. You're going to see a problem like this. At the, quote, indicated point, of y is equal to 1 over x minus 1 at x equals 2, okay? At this indicated point, please find a, which is the slope of the curve. So here's your actual function. You need to find the slope at that one point. Okay, so that's still the problem there. Let's go to Desmos really quick so I can graph this guy. So this doesn't just become another math problem. I want you to understand kind of conceptually what's going on. I'm going to graph this guy. I'm going to graph this equation here. 1 over x minus 1, okay? And then let's zoom in. So at 2, so we're trying to find, you see how if you can kind of guess, we can kind of see how we're guesstimating, like if you find out slopes between 2 points in here and here. I want to find the exact slope at that point. Why would it be difficult to try to take a bunch of slopes nearby and then to estimate what the slope of this guy is? Why would it be difficult to do that? Yeah, there's a lot of decimals, and not only that, like, do you see how like the slopes, it keeps getting steeper and then it gets flatter and steeper, right? Like, meaning this. Like if I took the slope here, from here to here, here to here, here to here, here to here, you have to take a bunch of slopes to kind of estimate, like between 2 points. Take a slope here, take a slope here, take a slope here, take a slope here. That's a lot of work. Okay, so this is why this technique is a little bit more efficient. The most efficient way is what I'm going to teach you in about a week from now, okay? So first thing that we're going to do is, now let's expand this window again. let's write that general formula. The limit of h approaches 0, that gap, over f of x plus h minus the f of x over h. And what you're going to do now is you're going to plug in the x value that we need to find the value at. It will be the limit as h approaches 0 of f of 2 plus h minus the f of 2 over h. Now, a lot of people, when approaching this problem, are just like, cool, that's it. Now I just got to plug in h and we're good to go. Anybody see a problem with plugging in h right now? Yeah, not only that, if you plug in 0 right now, like the way you normally solve limits is you try substitution first, you'd plug in 0, but you can't do that right now because that'd give me like an infinite answer, okay? Anything divided by 0 would give me like infinity, which isn't a real number, okay? So what we're going to do is we're going to write out the f of 2 plus h. I know it's going to stink, but what this means is you got to plug this guy in into the input value over here. Okay, so all this into here, so meaning you're going to have 1 over 2 plus h minus 1 minus the f of 2, so you now plug in 2 into here again, minus 1 over 2 minus 1, okay, over h. Okay, well, that was pretty quick math there, but okay. If I simplify this out, it'd be h plus 1 minus 1 divided by 1, essentially, which would just be 1. I know I kind of skipped a step there. There's many ways you can handle this, but I'm going to say that the fastest way is to multiply this whole thing by h plus 1. H plus 1, like this top and this bottom over here by h plus 1. Because I'm trying to eliminate this denominator. This guy times this guy would give me 1. This would give me minus h plus 1. Okay, so 1 times h plus 1 would be h plus 1. And then on the bottom would be h times h plus 1. At this point, you should be asking, is this even worth it? Because this seems like a lot of weird math. But just have some faith, okay? Have some faith. I know I don't have a lot of space. You guys can keep going downwards in your notes, but I'm just kind of lazy. I don't want to flip the paper. It's a lot of work to flip the paper, you know? So you're going to do 1 minus h minus, or h plus 1, which I think is 1 minus h. I think that will end up giving me just minus h. Is that okay to assume? To see that? Okay. Thank you for your affirmation. And I'm like, yeah, that's fine. And now here's where the beauty comes in. If you did everything right, things should nicely cancel out. I notice the h and the h are on the bottom and the top. They kind of cancel out, giving me 1 on the top and the bottom. So my final value is going to be 1 over h plus 1. Oh, it is negative. I'm sorry. Yeah, it is negative, right? And I know I didn't do very well on repeating myself, but all of these were limits. So don't forget that the limit notation was in front of all of this. So if you need to go back in your notes, you can put the limit as h approaches 0. You can re-put that back in to all of this if you want. Or if you can tell your brain, if you can remind your brain that this was all a limit, you don't have to write in limit for each one. Just make sure to plug it back in down here, okay? At the very end at least, okay? Now, can we substitute 0? Well, yeah. If I plug in 0 to h, 0 over here would be negative 1 over 0 plus 1. That tells me that the slope here is approximately negative 1. And for the most part, I'm not going to say that's wrong. I think for the most part, that looks like a slope of negative 1. That looks pretty accurate, okay? All right, why don't we take a math break in terms of you're going to do math more, so maybe it's for lack of a better term, I guess. I'm sorry. Your math break will involve you doing math. How torturous is that? That's so mean. Okay. There's more to this problem, but why don't you try this technique in finding tangent slopes for these following things? Okay, so we're going to find the tangent slope. You don't have to write this down. I'm just giving you directions here. Find the tangent slope at x equals, let's see, what do I want to do? F of x. At x equals 2 for the f of x as it equals the absolute value of x. Oh no, will this make it complicated? I don't think it will, okay? All right, guys, go ahead, find a space on the whiteboard. Try this out now, okay? Try this out. Everybody, come on. Get up, come on, guys. Shake it out, Get the blood flowing through the system, okay? Get the blood flowing through the system. Find a space on the whiteboard, okay? Turn on the lights. So can someone turn on the lights, please? Sean, can you get the lights for me, please? Thank you. Thank you very much. Yeah, that's it. Right? Is that so bad? I know it's kind of freaky, right? Yeah, h over h, right? Which is yeah. No, I know. How about even over here? What you said. That's it. Yeah. Okay, so what's the notation? Yes. Okay. Okay. I don't know if you're just being nice to me, but like, all right, should be fine. Yes, we'll do it. Okay. Let's do one more. Okay. Okay. You thought that was crazy. Oh, sorry. What did you guys get? Okay, just making sure. One. Anybody not get one? I think the only people I didn't really check in on with were Elena and Emily. You guys okay so far? That's kind of not conducive if I ask you like that. Are you guys good or what? Because we're all waiting. Okay, no. Sorry, it's not a good way to ask. Okay. Let's do the tangent slope at x equals 2 for, this is going to be slightly different, so it's going to be a little bit trickier, 1 over x. Okay? Try that one. Yeah, get up on the board. Yeah, please. Stay where you are, get up on the board. Yeah, Emily, that's what I'm saying. Okay. Emily, Risa, power team. Okay. Sean, Elena, super power team. Not to discredit Risa and Emily, I'm sorry. So just FYI, I'm definitely gonna make videos for this because we had a lot of other stuff I wanted to cover too, but sometimes I explain things at a snail's pace, if you guys can't tell by now. So I'll have other stuff up, and I do expect you guys to watch it. Okay. Otherwise, if you don't need my help, you guys can get to 2.4 without my help. But if you need assistance, then watch my videos. Okay. So again, when I put up the videos, watch them. This is not easy. This is not easy. Let me walk around. This next step is a hard one. So, Joseph, you're at the place where I want you to be. That's a toughie. Okay, so at this point, you need to get rid of what else is on there. So, you need to, what I would suggest you do is multiply the top by a number that cancels over this and this. That's going to be tough. Think of it. So, you're at the same place. So, you're at 1 over 2 over. Oh, so you multiply by see, you'll, no, you're right. It gets rid of this guy, right? Not only that, too, you multiply the 2 plus h. So that should, it's still let's get rid of the 2, right? So can I see the 2? You're like you're doing 2 plus h. That way, this cancels out, and then 2 goes up here. This cancels out. This. Try that. Try to make 2 over. Okay, yeah. I see what you're doing. Yeah, because you're just because this. I'm gonna give you guys some assistance here. It's like so like basically what we're doing is we're making 1/2 equal 2/4. It's the same exact number. I like the discussion. So it's stuff. Wait, how'd you go? Okay, so 2 minus. Okay, yeah. Okay, yes. And so I have 8 squared. me show you. Okay.
What half equals 2/4? It's totally fine.
It's a very hard problem. It looks deceptively easy, but it's actually really hard. All right, let's go ahead and stop for a sec. Okay. Stephanie, can you do me a favor and get the lights for me? I'm gonna. So I think. Let me see if I can stop you guys here. So here's the deal. I think all you guys got this conceptually. There is no worries about your conceptual understanding, okay? It's just the nitty-gritty math stuff. So that's why I think being the study group session is kind of good to clarify some techniques that we need to be pretty good at, okay? So here was where we got stuck, okay? I think my first instinct is to multiply the top and the bottom by 2 plus h because that's the nasty-looking denominator, right? But you might have ran into a problem. If I tried multiplying both this, the top, like the numerator and the denominator by 2 plus h, right? Because that would get rid of this guy. But then you got into this weird situation where you still had the 2 there, right? So here's one strategy that you don't have to do, but I think it's an easier strategy in my opinion. It might not be, okay, for everybody. But I multiplied the top and the bottom, not just by 2 plus h, but also by the 2. Why did I choose to include the 2 there, though? Because I want to get rid of this denominator as well. What? Because if I multiply this guy by 2 plus h, the 2 doesn't go anywhere. It's still there, and it still makes it look crazy, okay? So watch. If I multiply the top by 2 times 2 plus h and the bottom by 2 times plus h, let's take a look at the expanded expression. Again, I multiply everything, this guy and this guy, by 2 times 2 plus h. If I multiply 1 over 2 plus h by 2 times 2 plus h, the 2 plus h expressions cancel out, and the 2 goes here. It multiplies to that 1 there. And then if I multiply that minus 1/2 by 2 times 2 plus h, the 2's will cancel out, and I don't have a fraction to kind of deal with. And the bottom, I have to be fair. That was 2 times 2 plus h. Okay. And then let's take a look at our slightly cleaned up expression. That 1 and the 2 multiply. So you got 2. It's a nice clean number, no fractions. Up here, again, the whole reason why I did this is because I don't want fractions. I don't like dealing with fractions. Personally, I don't. Okay, like fractions within fractions is crazy. Okay, that's inception stuff. Okay, so you have 1 times 2 plus h. That's 2 plus h. Remember, you're subtracting that over h times, I guess if you want to be technical, you can put 4 plus 2h or something. I don't know. I don't know if that makes it any easier. I don't like where this is going at all, but then we got the limit as h approaches 0. That's 2 minus 2. So that's going to look like this. 2 minus 2 minus h. But if we want to save some space here, we realize that 2 and the 2 kind of cancel out over, what is it? H times 4 plus 2h. Mr. Wee, what's going on? But the h's cancel out. Whatever divided by itself is just 1, right? and then I get the limit as h approaches 0 of negative 1 over, I think it's 4 plus 2h now. Remember that 2h didn't go anywhere. Ask yourself now, that looks kind of clean, doesn't look like I can do anything else now. Can you plug in h equals 0 into this value? Yes, you can. If I did that, I would get an expression of, if I plugged in h of 0, that would give me negative 1 over 4 plus 0, because 2 times 0 is just 0, giving me a final value of negative 1 over 4. I'm not going to say it's easy. I'm going to be like, easy, huh? It's not easy. I think it's pretty tough because it just involves really high-level algebra, okay? But again, don't discredit yourself and don't feel beat up in any way because you guys got it conceptually, okay? That's probably the hardest thing about calculus, okay? So very good. Let me see if we have time for, I don't think we do. That means I got to make quite a bit of videos here. Okay, so I guess we'll stop right here. But guys, like I said, I'm probably going to make a few videos. That means by the end of the week, finish the videos, okay? I want you to be caught up. If you really feel like you got through 2.4 without any of my help, then don't watch the videos. But if you don't know where to start in 2.4, okay, hopefully this will get you kind of your feet on the ground and you can start running now, okay? I'm really bad at expressions and stuff, idioms. But for the time being, watch the videos as they come out, okay? All right, guys, that's it for class today. Go ahead and stack your chairs. I'm glad you guys came. Thank you guys so much. You guys have a wonderful day, okay?